Let's look at polynomial linear factors and zeros. But first, let's look at multiplicity. Multiplicity is the number of times a linear factor is repeated in the factored form of a polynomial. So in this example, the multiplicity of x equals 0 is 7. The multiplicity of x minus 9 is 5. The multiplicity of x plus 11 is 3. And the multiplicity of x minus 2 is 1. Now, we can also say that x equals 9, which is a 0 of this, has multiplicity of 5. And x equals negative 11 has multiplicity 3, and so on. The one students tend to forget is this one right here, and we would say x equals 0 has multiplicity 7. A lot of times when they're not solving for like x plus a equals 0, they drop it. Now, what does multiplicity have to do with the graphs? Well, the multiplicity shows you how the function is going to look close to that 0. So if it's a linear factor, all right, close to x equals 5, the graph is going to look like a line. While near x is equal to negative 4 has a multiplicity 2, it's going to look more like a quadratic, and so on. Let's talk about roots, zeros, and intercepts. These all mean the same thing. X minus b is a linear factor, all right, is an equivalent statement to b being a 0 of the polynomial, or b being a root to the polynomial, or b being a solution to the polynomial, or b being an x-intercept of the graph. So we're always asking for basically the same thing. You want a factor, set the factors equal to 0. As a matter of fact, the factor theorem says, and this is important, it's been named, the expression x minus a is a factor of a polynomial if and only if, there's my biconditional, a is a 0 of the polynomial. So let's see if we can find the factored form of x cubed minus 2x squared minus 15x. So the first thing you always want to do is see if you have any common terms, and you do. So you're going to factor x out of this entire thing. So I'm left with x squared minus 2x minus 15. Now I'm going to use all of my factoring skills, and I need two numbers that multiply to be negative 15 and add to be negative 2. And so that's going to be negative 5 and plus 3. So this is the factored form. The zeros are x equals 0, x equals 5, x equals negative 3. They all have multiplicity 1 because its power is 1. Now, if I give the polynomial to you in this way, and I ask what are the zeros, well, I've got 1 0 at when x plus 2 is 0, or x is negative 2. So when x is negative 2, there's 1 0. When x is 1, I have a second 0. And when x is 3, I have another 0. Now, I know this is a third order polynomial, so I know it's going to have behavior down and then up. So it turns out I can do a quick and dirty sketch. What is a cubic polynomial function in standard form with zeros, -2, 2, and 3. So I'm asking, what is a polynomial that has x minus a1, x minus a2, x minus a3, where a1 is equal to -2, a2 is 2, and a3 is 3. So substituting these in, this is x minus -2, x plus 2, x minus 3. Ah, great. Let me multiply these two together first, because what is this? X plus 2 times x. Oh, I dropped my negative. Plus a -2. Plus a -2, this is a difference of squares. So I'm going to get x squared minus 4. So a lot of times on these, it's easier to just go do the area model. Now I'm going to multiply x squared minus 4 times x minus 3. So this is x cubed minus 4x minus 3x squared plus 12. So my polynomial is going to be x cubed minus 3x squared minus 4x plus 12. It's a cubic polynomial, standard form, with the following zeros. Suppose I want to factor this polynomial. Well, it's x to the 4th minus 2x cubed minus 8x squared. Fill out your your common factors here. So I'm going to pull x squared out. Now I need to factor x squared minus 2x minus 8. What multiplies to be 8 and adds to be -2. Okay, and that is x. Put your x's here. X plus 2, x minus 4. So I've got my factored form. What are my zeros? The zeros are when x is 0, x is equal to -2. Don't know what my pen is doing. And x is equal to 4. What are the multiplicities? The multiplicities of x equals 0 is 2. The multiplicity of x equals -2 is 1. And the multiplicity of x equals 4 is 1. And how does a graph behave near these zeros? Well, this one, it will behave like a quadratic. This one is linear. And this one is linear. If you want to find relative maxes and mins, well, let's look at this one. We're going to need to factor it. F of x is, let me pull an x out, x squared plus 3x minus 24. Now, this is not going to factor very well, so I'm going to go to my technology. And here, I have it graphed. And I see that I have a relative maximum at this point right here at x equal to -4. And when I substitute this in, to the equation, I'm going to get 80. So I have a maximum at -4, 80. And my minimum, my relative minimum, will be right over here at 2. So when I substitute that in, this is 2 cubed plus 3 times 2 squared minus 24 times 2, I'm going to get negative 28.